Hello, ladies and gentlemen, and welcome back. We are going to finish off Part B in this video with question number 20, and that is Part B on our 2016 Cayley paper, for those of you who were wondering. What have we got? There are N students in the math club at Scoynes Secondary School. When Mrs. Fryer tries to put the N students in groups of 4, there is one group with fewer than 4 students. So 1 student, 2 students, or 3 students. But all the other groups are complete. When she tries to put the N students in groups of 3, there are 3 more complete groups, so groups of 3, than there were groups of 4, complete groups of 4. And there is again exactly one group that's not complete, but since it's not complete and there are groups of 3, this non-complete group should have 1 student or 2 students in it. When she tries to put the N students into groups of 2, there are 5 more complete groups than there were groups of 3, complete groups of 3. And there again is exactly one group that is not complete. But if we're putting groups of 2 and you've got a group that isn't complete, well, it can't have 2, it can't have 0, otherwise it's not a group. You're sort of forced to have 1. The sum of the digits of the integer equal to n squared minus n is... I get the feel, I think this question was on the Pascal paper for this year as well. Anyway, I think for the Pascal question, I started at the end, because what caught my eye about this was when she tries to put the groups of 2, you have something left over. I know what that remainder is going to be, whereas splitting them up into groups of 4, I don't know what the remainder, what the leftover amount of students is. So I think that would have been in part C on the Pascal for the 2016 Pascal. I think it was probably question 22 if my memory serves. But if you're looking for one way to do this question, I would recommend you can go look at that. What I'm going to do is I'm going to do the opposite. I'm going to start with the groups of 4 and try and work it out rather than the groups of 2. I think the groups of 2, because the remainder, is the smarter way to do it, but I want to show off both possibilities. So one video for each. So I know that n is, say, 4k plus some remainder. And the remainder, of course, is 0. It can't be 0 because it is a group. So it's 1, 2, or 3. We also know it's 3 times some number of groups. Okay, 3 students per group. And we've got 3 more complete groups than we did before. And again, plus some remainder. 1 and 2. And then finally, we've got n is equal to 2 students per group, and we have 5 more students. So k plus 3 plus 5 is actually k plus 8. And this time, again, we know that we're going to have a final remainder of 1. You could call it t and say t must be equal to 1, but no, don't waste your own time. It's a 1. Okay. So first thing I can see right away, n is going to be an odd number. It's a multiple of 2 plus 1, and that rules out r being equal to 2. It doesn't tell me anything about s being 1 or 2, but that's okay. Okay, but I know r can't be 2. All right. So where can we go from there? Well, we'd like to do some sort of expression. Maybe we can realize that, hey, they're all the same thing. They all express n, so maybe we start equating them and we can learn things about k or the possibilities for r and s. So if I take the first 2 equations and equate them, just expanding things out a little bit, I'll get 4k plus r is 3k plus 9 plus s. If I subtract 3k from both sides, I get k plus r is 9 plus s. Okay. Well, I know s is at most 2, at least 1. R is either 1 or 3. So this might give me some sort of limit on k, but frankly, there's too many variables here. So instead, let's try and use this third equation. Maybe equate the second and third equations. We know they're both equal to n. So we get 3k plus 9 plus s is equal to 2k plus 16 plus 1. Or 17, I guess you could say. If I subtract 2k from both sides, I'll get k plus s, and if I subtract 9 from both sides, I'll get 8 over here. So k plus s is equal to 8. Well, s is either 1 or 2. So that means k is either 7 or 6. And I guess we could probably just try this out. You know, take that k, take a choice of k, and plug it into this third equation. You'll know what n is right away. You'll know what s is by your choice of k, so the question is, do we get an r that works? Okay, so let's try k as 7. So n would be 2 times 7 plus 8 plus 1, and that'll be 2 times 15, that'll be 30 plus 1, so n could be 31, maybe. Now in this particular situation, since k is 7, s is 1. Okay, so we're not going to check this second equation. There's nothing new to be gained. But this first equation, n is 4 times k, well k is 7. So 31, is that 4 times 7 plus something that's either 1 or 3? Well, 31 is 28 plus 3, so that seems to work. Okay. But couldn't k also be 6? Let's rule out that case, because if both of them seem like answers, we've got a bit of a problem. Now, if we tried k is equal to 6, we'll get 2 times 14 plus 1, we'll get n is 29. S would be 2 in this case. That's fine. But 29, is that 4 times 6 plus something that's either 1 or 3? Well, no, because 4 times 6 is 24, and so r would end up being 5. And 5 is definitely not one of the possibilities. You could get another group out of that. Okay? So we can see that 6 won't work. We just happen to stumble upon the right k first try. There were only 2 things to try, so 50-50 chance that would have happened. Okay. So we know that n is 31. But 31 wasn't one of the possibilities because we're not asked for n itself. We want n squared minus n. Well, now that I know it's 31, do 31 squared minus 31. 961 minus 31, you'll get 930. And the sum of the digits is 12. And that's going to be our answer. And 12 is B. So we can bubble in B. And we can get ourselves a fresh sheet of paper because we're going to have a fresh start as we begin Part C in the next video with question 21. Once again, I would invite you, if you haven't already taken a look at those next 5 questions, to try it right away. You can get a copy of this contest by clicking the very first link in the description. Try the next 5 questions, see what you can make of them, and then come back because we're going to go through question number 21 in the next video.